Hello, everyone, and welcome back to talk 2 of this session. So today we have Ramon Perez talking about building with multiple languages, a Python-first approach. And this is Ramon's first PyCon AU. So give him a big, warm PyCon welcome, and I'll hand it over to you.
Fantastic. Thank you, Ash. Good morning, everyone. Yep, it is my first time speaking at PyCon Australia. I have nonetheless spoke at quite a few conferences, fortunately, across the world, and some of them PyCon, some of them SciPy, some of them different conferences around programming, but I also don't want to perk up myself too much because then I don't want to disappoint you guys if it's too bad, and if I make a mistake as well. So yeah, so at the beginning of the year and throughout the last 2 years, I have been building with different languages, and in particular, since the beginning of this year, I was working on a tool that uses C++ and uses Python. And before, I had a lot of appreciation for the things that Python does really well. And after working with C++, I have an even greater appreciation of what Python does well. So take that as you may. It's not negative, nor it is, it's a very neutral comment. So today we're going to be talking about how to build with multiple languages. I'm going to show you a bunch of examples. I have a lot of live examples, and I have figured out how to connect components on the browser to my slides with a server running on the background with the things that I'm going to show you. So hopefully that goes well. We all know the demo gods sometimes are not very welcoming of people, of us, mere mortals in the programming land. So, all right, so let's begin. So the usual options when you want to build with multiple languages are usually you accept the pain. It is fine, we can wait 30 seconds. The famous last words without getting fired, those might be. And then the option 2 is like, let's rewrite everything, our entire ML pipeline in Rust or whatever it might be. 18 months later, you're still sort of trying to figure it out, but it's coming along well. Now, that's not to say that there's not fantastic programs and projects that have absolutely nailed execution on both ends of the spectrum, the low-level programming language and also the more high-level programming language. So that's just, a very broad take on both aspects. But then, so if you think about Python, I think this analogy has been used before, but I'm also going to take it as well. Like, it's kind of like an orchestrator or a maestro in an orchestra where you have all these programming languages and you want to bring them all into one place. So you have the JavaScript, where you can do real-time UIs. You have Rust, where you can do a lot of heavy data processing, and not just data processing, but a lot of things that perhaps are better handled by taking advantage of all of the resources in your machine versus only some resources in your machine. And then the other piece. Oops, I went a little bit ahead. But rather than orchestrate everything, we can actually glue a lot of things with Python, and so. This is not new. Python was released officially in 1991, and it was designed as a glue language for C libraries. And as a matter of fact, the actual name, I don't know if some of you know this, but the actual name of Python in the repo of Python in GitHub is actually CPython. And so it also alludes to the fact that it is built on top of C. So in 1995, NumPy started wrapping BLAS and LAPACK, which are Fortran libraries. In 2007, Cython made its debut, where it started giving us a nicer interface for writing low-level code in C, and then also being able to still stay in Python land. Then in 2016, PyTorch was officially released with Python bindings on top of C++. I believe before that it was written in Lua. And then in 2023, half of Python's ecosystem is now running on Rust. That's a bit of a joke. No, it's not every project out there, but so the web stack that you're using right now most likely also have a little bit of a component with Python. You might have the front end or you will most likely have the front end in JavaScript and so on. But the most notable examples today that you might recognize is that Jupyter notebooks are in the front end. They have pure JavaScript, I believe the actual notebook, and there are some implementations that also use frameworks in JavaScript that are React and so on. But then you have the kernel, which is the thing that runs the code that you execute from the front end and send it to the back end, and that is written in Python. You have PyTorch, which is core C++ and CUDA. CUDA is also in C++ with bindings into Python, and then it compiles using the LLVM compiler. Then you have mother tooling like UV, written in Rust. You have Rough, you have Pydantic, which recently released their V1. They have a really fantastic, fantastic product. So then you also have the Linux kernel, that has the committee, and the people behind the Linux kernel has recently accepted, to my knowledge, a couple of contributions written in Rust. So the division of labor for this talk is that we have a few practical patterns. I want to show you one of the most, to me at least, difficult things to do when you get started building with multiple languages is how do I architect the project that I have? What do I put in each directory and what do I put in this other one? How do I build the skeleton of my Py project.tomo if I'm still using that? If I'm using that one, there are people that are still using setup.py and so on. There's nothing wrong with either approach. But how do I architect a project if I have decided to go down the route of building with multiple languages? And then we're going to talk about a little bit of production ready, in quotes, because I am going to show you a couple of things that work in here, but from here to a server that you have to monitor, there's a few caveats. So I am also going to show you how would you approach deploying those services and put them in production and test them. I'm going to give you a matrix of steps that you can take and follow so that you can scratch each one of those off as you do. So the part one, let's talk about architecture. So when you think about a decision tree, or just a set of decisions to start to say, like, I am going to use or follow the polyglot route. You say, is Python actually the bottleneck? Or is it, I am guilty of this, is it really bad written code? It could very well be. So profile first. Is Python slow? Python is slow, it's not the profiling. Okay, fine, fair enough. Can you solve it with a better algorithm? Sometimes we can throw a bunch of numbers and the complexity grows linearly. Sometimes it doesn't. But if it doesn't, okay, fine. Is it worth the complexity? Well, let's rewrite it in Rust. Things said 10 minutes before disaster. And which, again, is so a fun take on it. I like the language. I think it's fantastic. There's some value to get from every single one of the languages that have had so much love and care put into it out there. So if yes, then do embrace the polyglot and then go follow that route. So the 90-10 rule is that whatever you can offload to Python, actually do keep it in Python. So if you have some data loading and that has already been written, don't rewrite it just because you think you can make a better data loader and it's already there. And also, I'm just giving you rules of thumbs. The configuration piece, Python is fantastic as a configuration language. So perhaps there's no need to rewrite that in the other language that you're about to add to your project. And then error handling, APIs, and UIs, perhaps all of that can actually be managed by Python. There are instances where it perhaps shouldn't, but that's up to you and your team to decide. The 10% of your code that does do the heavy lifting, then do the number crunching, do the real-time processing, do the graphics rendering, do the network protocols, and so on. So optimize the 10% and offload the rest is the key takeaway of that. So common patterns. Now we get into what exactly are we going to do. So the first one is the sidecar. There's a fantastic book called Data Science at the Command Line that teaches you how to do a lot of really cool stuff and really interesting stuff from the command line. And one of the easiest places to get started with when you are building using multiple languages is that if you already have the package that gives you the 10x boost, or you already have the library that allows you to do a lot of complex stuff, and it is implemented as a CLI, then you can call the subprocess.run and then run that thing from Python, so long as it is available in the host operating system. So then the second pattern is, well, perhaps we do a microservice. So if you don't interact with a different programming language, with the kernel of a operating system directly, with specific functions that you really need to tackle directly, then the next best thing is to put them in a server and then connect to them or talk to them via localhost, via HTTPS. And then the third pattern is, well, build an extension, build bindings for that module. So what I'm trying to hint with this, or what I'm trying to allude, is that there's two steps before you actually have to create bindings for connecting Python to another project. And then the last step is, like, you can actually create a bridge where you are talking via real time, via WebSockets. That has a little bit of, it can add a little bit of complexity, but it can definitely improve the speed. And I would actually move this one before the extension, before the actual bindings. Okay, so if you think about a data flow architecture, you have your Python orchestrator, you have the data validation, and then you have the switch, where you say, is this performance critical or not? If so, then can I offload it to another programming language, to something low level? Or is this something that I just cannot display? Can anybody tell me why is the main reason why we combine JavaScript with Python? The browser, exactly. And why do we go to the browser and not to Pygame, for example, to create a game or to do something else? Sorry? Accessibility, yeah, distribution. The browser is the biggest graphics engine that just gives us access to distribution immediately. And sometimes the decision is not necessarily about performance, but it's just about flexibility. Should I make a native application and spend a lot more time configuring that and making sure it runs on every device and every operating system, or should I just worry about the browser that the user has? Sometimes the latter is better than the former. Okay, so the integration matrix. Go via sub-processes if the tool is already, if you can assume that the tool is already available in the operating system. If you're putting this on a server, you have complete control onto what gets installed into that server as well. So go via the sub-process route if it's already there. Go via the HTTP route if you know you can put that thing on a server and you can communicate via APIs. And then build the native extensions if you do have to. So sort of increase the complexity as you need to, not because you want to. Sometimes it's really fun. Okay, so yeah, the rules of thumb is start green, move right, and then when necessary. Okay, so when things go wrong, don't rewrite it in another language for the sake of it. I think I alluded to all of this. Profile first, clear out the requirements. I think that's the biggest thing that we need to take into consideration. Clear out the requirements. Assume that you can write. Don't assume that you can rewrite faster than you can optimize. Don't start without a performance target, and be careful to not to micro-optimize the wrong thing as well. I have been very guilty of that one as well. Document the integration. Document everything you do, and especially these days, if you are using AI to help you write your code, always have a to-do .md file. Have a explanation .md file, and something that I do if I have AI help when I'm writing code is that I have a tutorial .md file, and I force it to write in the rules. I force it to rewrite the tutorial if something has changed massively, or if I have changed something for better or for the worse. Okay, so the build patterns. So let's talk about the project structure. This is probably the most important thing that you need to keep in mind, because you are going to have to attach things and put things in different places, and sometimes it's just not obvious. Where should we put things, where, and why? So in the evolution of a repository, you're going to have your project, your PyProject.tomo these days, which is a fantastic way of organizing all of the things that are going to go into your project. Then you're going to have your source directory, your package is going to be in there, and perhaps other packages that are part of the bigger ecosystem. Then you're going to have your app.py, and then your init to let it know that it is a package. So you're going to have your test, and then everything is going to be in those. Like, if you want to keep it as minimal as possible, you can have these 3 things, and that's it. But if you want to make it a little bit more, if you are going to add JavaScript, then this moves around a little bit. So the biggest component, or the biggest switch that you need to keep in mind here, is that you could have the front end inside the source directory, but the caveat is that when you build the wheels, when you build your Python package, it is going to take everything inside that source directory. So the reason I have the front end out here and the static you still see the static underneath inside the source directory is because what we want to do with the front end is to build that. And we're going to get something called the distribution directory. That distribution directory, or that output from the bundler, we're going to add it to the static folder. And then from that static folder, if you have used Fast API before, you're going to have something called bring in template or bring in static files. And then you bring them into your API. And now you have Python running in the background, sending to the user something in the browser. Then why do we have the scripts there? The script is because you're going to have to build that distribution. And that might be something that you add inside your CI pipeline, inside your build process. So you add that little script over there. It might be somewhere else. It might be part of the CI itself, and you might not have something here. But separate the concerns and where possible, keep the, well, that's my opinion, keep the front end separate, just because it is so easy to forget that if the front end is in the source directory, you're going to have to do some magic to get it out of there and only include the static files, and that is all you want. You want the stuff that is going to be displayed on the browser to be as minimal as possible, and also you want to reduce the size of your build package. So this is the key component for your Python stuff. You have the server is going to bring in that file, the static file, and so on. So then, if we go to Rust, how is Rust going to be arranged? So we're going to have that cargo.tomo file, which says what versions, what packages, and what versions of those packages am I going to be pulling in to compile the source code and then create the binary object. So then you're going to have the Rust implementation, and then you're also going to have something called, perhaps you're using Pyo3. There are a few more tools in Rust that you can use nowadays to create multi-language projects. I think Pyo3 is sort of the most popular one right now. So you're going to have in your source directory now, you're not going to have your Python there. You're going to have your Python inside a Python directory. And again, this is a stylistic choices. I'm giving you a high-level overview so that you know how to separate your projects when you do build one. Also, the tools that you might use today might do this for you, this rearrangement of concerns for you, which is also really nice. Then you're going to have the whole that is going to be that's going to be your project, and then you're going to have a directory for the target for the wheels, the thing that you are going to create, the Python package that you do pip install. In these days, UB pip installs. And then for C++, you're going to have something similar. You're going to have the implementation somewhere else, and then you're going to have something called PyBind, PyBind 11. There's different ones that you can use, but you're going to have sort of the same layout. And now you're starting to see a pattern of separation of concerns between the Python code and also the C++ code, the low-level code, and the front-end code. In one aspect, we still want to keep Python sort of like the main thing of the library, of the package, but in some others, we have to treat the low-level code with a little bit more respect, let's call it that. So we have the project, we have the C++, and so on. I also had another one. I have gotten very interested in a programming language called Zig, so I have a few examples here. I am not sure I'll be able to show them because I have so much content. There's 90 slides, and I'm only in 16 right now, so I'm sure I won't make it anywhere near half the talk, but I hope I do. And I do have a couple of examples using Zig, which is a fantastic programming language. So I'm gonna skip it. I'm gonna try to go a little bit faster here, just because there's many things. So you're gonna have build system. This is where a lot of the magic happens, and a lot of things just get put into the right place where they need to be for the directories to be sort of put into one place completely. So you're gonna have the JavaScript. You're gonna have to build it with npm run build, and then you're gonna have the static assets that your server pulls in. Then for Rust, C++, and Zig is sort of the exact same process. You're gonna have this binary, this blob object that then you're going to use Python using foreign functions interfaces to bind Python code to that code. Okay, so in development mode, you're going to see the output somewhere there. You're going to run npm run dev, Python server, it starts, it captures everything. Maturing, develop, pip install -e, and so on and so on. Then the production mode, you're going to have the package that wheel for Linux, for example, and then it's going to be very minimal. You're going to have the native .so, whatever library you're using. You're going to have the Python-specific information, and then everything is going to be bundled very, very specifically in one single place. And by the way, so these slides are in a repo. This is using SlideDev, so I should have put the repo at the front as well, but I'm also going to show it at the end of it. So in CI, the most important thing is this thing. Where is my package going to be used at? So you want to make sure that whatever you're doing to test that package, you do so with the intended programming languages, operating systems in mind. So if I am going to be running this in Mac OS or Windows latest, like make sure you do it, you run tests in each one of those platforms so that your CI process screams at you if it does not like something. And then you're going to have the steps where you're going to run through how to build the static files, how to build the binary object, how to make sure everything just runs smoothly. So I'm just going to skip through this one. So testing with multiple languages. Testing is more an art than a science a lot of times, but you want to make sure you test your Rust boundary. So you test sort of the intersection between is the code actually really being read by Python, and am I passing the right data types into the systems level binary block? Am I passing data fine between one or the other? So that's probably the biggest takeaways that I struggle with while doing C++ and Python. So make sure you run some tests on this. Don't leave it towards the end. Ask AI to do them for you. That's what I do these days. So, okay, so the cost-benefit analysis is that if you have a 100 millisecond endpoint and then it takes 10 milliseconds, perhaps it's not worth it doing something else. But if you go from 10 seconds to 0.1 second, then do some rewriting or put some thought into how can you extract more performance while still staying in Python land. Real-time audio is pretty much, you're going to need something very low level to do that well. And then UI interactions, you're going to need JavaScript. All right, so I have a few things here on the rules of thumbs and development time, debugging complexity, team expertise. You have to take all those things in consideration. So some of them are a little bit more cultural and part of your organization. So who is there? How much time can the company devote for somebody to spend, say, a couple of weeks learning something new versus can we hire somebody faster than somebody can acquire that knowledge as well if you are going to go and add specifically a low-level programming language and nobody in your team has that expertise. There's going to be some trade-off there. Okay, so packaging expectations. This is what we all want. Pip install your package, but I'm sure everybody here has probably gone to a repo, and before you get to the pip install, it tells you, well, you're going to have this, you're going to need this one, this one, this one, this one, this one, and this one in your operating system. And you're like, what? How do I do that? And sometimes if you run Linux, then they're only going to give you the Debian or the Ubuntu explanations. Then they might have 10 different names in other operating systems. If you're in Mac, then you just don't pay attention to it. If you're in Windows, no, I'm joking. If you're in Windows, you definitely don't pay attention to those. But okay, so I'm going to skip this stuff. There are packages out there that can help you quite a lot. There's CI build wheel, which is fantastic, and it allows you to test for each platform. So definitely check it out. I'm going to put a couple of things here when builds break, but I'm going to skip to the next section because I want to go through some code examples. And in particular, so working with different languages. So say, for example, we have, so I am from the Dominican Republic, and I picked Santo Domingo here. So the distance from Santo Domingo to Miami is simple enough. We say we are in this longitude and latitude, and then Miami is in this other longitude and latitude. How do we actually accomplish accessing that? But don't pay attention to that function because it means nothing. Like nowadays is just one simple one function. So from that to that, I never want to see that in my life. This is so much nicer. So I just wanted to scare you a little bit and then keep you engaged until my time runs out. So if we have the Python one, so say we have the longitude or the latitude, we have two places that we want to calculate the distance of. And I have a point on showing you this function. I'm going to show it to you in 4 different languages, and also I'm going to show you the difference in speed. So we're going to do some calculations. We're going to subtract something, add something, and so on, and then we're going to return something, right? So how does that look like? What does that look like in different programming languages? So it doesn't look that scary. It doesn't look that much more complex. There are nuances between switching from one language to another, but when you get to the core of it, you start seeing the things that we're using, say, for example, now in JavaScript. So I am using the exact same arguments in a function. I am creating different destructuring in the same way as you do in Python. The map is a little bit different because they have it at the end. In Python, we have it at the beginning of the function and so on. But things look relatively similar. If you go to the low-level programming languages, they do a little bit of ceremony before they tell you what they're going to do. You have to explain 10 times why you're going to do it. But still, it's kind of similar. If you see Rust, it has a lot of similarities with JavaScript. If you see C++, then I don't know what they're doing, to be honest. There's some stuff happening. And then if you see SIG, it's a little bit more human-friendly. STD, standard library, math, that, degrees to radians. It's a little bit more palatable. I still, C++ still very respect. And, okay, so performance check. If you were to test this function, and do 1,000,000 calculations, if you run it in a loop, Python would take on a million of this, about 2.1 seconds. JavaScript would take 0.8 if you run it in Node. If you run it in the browser, it's a different story. If you open the console there, it's still technically being run in Node. Rust, 0.12 seconds, and then C++, 0.08 seconds, and then Zig, 0.07 seconds. But that's just one function. I just wanted to give you a highlight of the difference in speed. If you have 1,000,000 calculations and you map that to 1,000,000 users, you have a nice product. You are perhaps a startup. If you are somebody or an organization that has 10 million users, 20 million users, 300 million users, this is not 2 seconds anymore. This is a lot of time to run something that perhaps is happening on the server and is going to be passed up to your UI. So there's a lot that we need to capture or a lot of information that we need to take into consideration when we want to increase performance. 5 minutes. Okay. So let me see if I can get to the real-world examples. All of my projects, they follow the same thing: show the problem, profile and measure, polyglot solution, and so on. So for the first one, for the JavaScript, I thought, okay, so there's modern agricultural monitoring, which requires real-time data streams, interactive dashboards, complex simulations, and easy deployment. The dream list. And then you're going to want to do something like, okay, let's read the sensors. Let's get the stream from the sensors. Let's create a loop, and then let's process that data. But once we finish with that data, okay, what are we going to do? How do we pass it in real time to the UI, to the user interface? So I have here a little package that I created called Outback Monitoring, because I wanted to keep a Australian theme. So actually, out of the 4 projects here, 3 of them have a theme with Australia. So this one is the Outback Monitoring. And so I have Fast API on the server, NumPy for the simulations, then a little CLI, and then JavaScript, real-time charts, WebSockets, and so on. So then in the Python side, I have Fast API, I have NumPy, I have different regions: Queensland, New South Wales, Victoria, I don't know anymore. Joking. Data simulation, so generate the data, create a little bit of simulator data, and then continuously pass it via WebSocket towards the front end. So then in the front end, I have the Outback Monitoring, I have my localhost set up, the region, I take the region, and then I take in that influx of data, and then I create a little chart, this chart's environment, yada, 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 and then we pass it to the front end. So what does this look like? So I have the CLI, I start my Python server, I run the simulations in the background constantly in a loop, and then I pass in via WebSocket. All right, so then this is the Outback monitoring thing. So let me see if I can, if the demo gods are with me, and the Outback monitoring, and then I'm also going to show you run. Okay, so we're gonna go with Queensland. Okay, so I have it now connected, and so I didn't set it up so that if I put no open, it still opens up a different UI because I have everything combined. So I just started the CLI, and then I select the region. I'm going to go for Queensland, and then I'm going to click Start. So now my simulation is in the background running, and then NumPy is passing that data real time into the component in my slides. So this is happening right now, and it's really cool because you can see like, okay, cool. Like now I have something happening in Python. Python works really well for this, and then I can pass it to the front end and business as usual. Right? I don't need to go to a low-level programming language. I can do it relatively easily, relatively simply. In the repo, when you capture it at the end of the talk, all of these examples are there as well, so you can run them yourself. So the biggest takeaway that I wanted you to get from this is that the developer experience is the most important when we create something that we're going to share with someone. And in this use case, where I create a static file and I can bundle it into the Python project, then I can start and say Outback monitoring, boom. And then I can say, I can start my CLI with one command and so on. So I have about 2 minutes, so let me see if I can get you the Rust one, because I want to at least give you a perspective on the low level and a perspective on the high level. So real-time web interface, interactive visualizations, and so on and so on. So Python and Rust. So here is where things get tricky. The thing that I picked was bushfire simulation. So this is important. This is very related to Australia. This is needed to be able to monitor. Okay, so what's going to happen if we get a fire? Can we simulate how quickly it is going to spread and to where? And one of the ways in which we can do it is via different algorithms that already exist. The key thing is that if you're running, say, an automata algorithm and you're trying to calculate what happens in a grid of 100 by 100 cells and which ones get turned on and off with the fire, then you have multiple simulations and you have a synchronous function running. Have anybody done any async work in Python? No? Yes, one person in a room with a lot of people. That is that is the point that I wanted to highlight. It's not extremely intuitive at first. After you work a little bit with it, then it does become much more intuitive. And this is also why Python 3.14 is about to, I believe, have the option to use no GIL, I think. Don't quote me on that one. I think that's how it's going to run. But anyways, I wanted to show you the example, because we have a simulation function that in Python just doesn't run very well. It takes about, for 100 by 100 grid with 50 steps each, is about 5,000 cells updates. This runs in 2.25 seconds. Australia doesn't, you cannot cover Australia with a grid of 100 by 100. Let's just put that way. So it takes performance to do a simulation when it's bushfire season, let's call it that. And so, same setup. I'm going to skip this because I want to show you the demo on what it looks like. The pipeline is slightly similar, and similar to what I show you with the bundling piece. And then let me see if I can get to this one. I have about 1 minute left, maybe not even, and I'm just taking advantage of the kindness of everyone here. So, bushfire simulation. Okay. And the demo god said no. We're not going to do it today. Yeah, sorry about that. I don't know what I did here, and it's been too many branches that I went through. So sorry about that. But the example is going to be in the repo. Check it out. And then also you can run it with these slides. If you like the slides, copy them, use them. I have a lot of components that you can bring in and make your slides more interactive. So for the last thing that I had for all of you was just a thought on Python, and I'm trying to get to the end to just tell you that thought, so I'm just going to tell you. There's a lot There's a lot of resources available out there to get started running multiple programming languages in via Python and having Python be your orchestrator. Take advantage of those. Explore. Especially, there's never been a better time to learn how to program in different languages while still taking advantage of Python than today with all these AI tools that are here. So thank you very much for listening to me. It's been a wonderful conference so far. Thank you.